All right, let's get going with chapter 4, risk identification. Introduction. Now I got this bold for a reason. The process of assessing risk is considered the core of risk management. Okay, got that? The process of assessing risk is considered the core of risk management. The fundamental process of risk assessment enables those responsible for making decisions to better understand the risk and its need for reduction or management. So risk management consists of 3 things. We're going to talk about them, all of them, but risk assessment rather. So the fundamental process, again, of risk assessment enables those responsible for making decisions. So the people making decisions on this stuff might not be the people looking at it. So if you're the safety person and you're looking at this stuff, you might not be the one making the decision as to, are we going to spend the money to do this? So risk assessment embodies 3 distinct sequential components: risk identification, finding, recognizing, and recording hazards. That's what I'm going to talk about in this chapter. Risk analysis, understanding consequences and probabilities and existing controls. That's the next chapter. And risk evaluation, comparing levels of risk and considering additional controls. And again, of these 3 elements, these are all under risk assessment, these 3 elements. Risk identification is arguably the most critical aspect of risk assessment. Why is that? Well, for a risk to be managed, it must first be identified. So if you can't identify it, you can't assess it. Otherwise, unidentified risks remain unknown and uncontrolled. Unidentified risks sometimes will get you, because a lot of times when something happens, everybody, including the safety person, says, whoops, they didn't know about that particular thing. So there you are, the risk assessment here, the core of this thing in green, and that covers these 3 things: risk identification, risk analysis, and risk evaluation. Risk identification and the ISO 31000 series. As mentioned in previous chapters, the ISO standards, 3 standards are vocabulary for risk management principles, and then risk management techniques. I'm not going to spend a lot of time on these, reading you all these ISO numbers. It's important to remember that these standards are designed for managing risks of all types, including risks that have potential positive outcomes, as well as risks that present negative impacts. All right, positive outcome risk would be usually financial. You're going to put the money, we're going to put it in here, here, here. So you have potential or negative, but you also have potential positive. But in the safety business, our risks are generally potentially negative. Somebody gets hurt, or something breaks down, or something in the environment, or as there's a damage to the environment. So it's almost always negative impacts. So the ANSI prevention through design, assessing risk focuses on assessing and reducing hazard-related risks during the design and redesign phases. And Z590.3 incorporates the concept of hazard analysis in the risk assessment process, but ISO 31000 does not include risk hazard analysis, only risk analysis. In addition to identifying hazards, ANSI Z590.3 includes the need to consider the failure modes as part of the identification process. Failure modes refer to a state or condition where a system fails to perform correctly, possibly resulting in harm. We're going to talk about this later too. Failure modes include functions that do not perform within a defined parameter, perform adequately or intermittently, or do not perform as intended. And the difference in relationship between hazards and risks are important to understand. Risks are derived from the exposure to hazards. ANSI Z590.3 definition: hazard, the potential for harm. Note, hazards include all aspects of technology and activity that produce risk. Hazard includes the characteristics of things, equipment, technology, processes, dust, fibers, gases, materials, and chemicals, and the actions or inactions of people. Hazard analysis is the process that commences with the identification of hazards and proceeds into an estimate of the severity of harm or damage that could result if an incident or exposure occurs. Risk is an estimate of the probability of a hazard-related incident or exposure occurring and the severity of harm or damage that could result. So you have probability and severity. That's your basic foundation for a risk matrix. Prevention through design standard is unique in that it is designed to be applied throughout the life cycle of a system, including pre-operation stage, you're buying it, even planning on it, putting it together, operational stage, it's running, that's usually the longest stage. post-incident and or post-operational stages. The standard also contains the hierarchy of controls concept used for selecting and applying the most effective controls for the hazard. For these reasons, Z590.3 provides guidance that is more closely aligned with the roles and responsibilities of occupational safety and health professionals, because they result in negative impacts, most basically. Hazard risk identification involves finding, anticipating, recognizing, and describing hazards that could affect the achievement of an organization's objectives. Specifically, the process of hazard identification, identified in the next slide, includes identifying the following: existing and potential hazards, potential exposures to hazards, possible failure modes, events or circumstances that can cause or trigger a failure mode or present an exposure, existing controls, potential consequences. This is the risk identification. Hazard risk identification is all identify hazards, identify exposures and failure modes, identify causes and triggers, identify controls, identify consequences. So hazard risk identification, existing and potential hazards. Identification of hazards is the most important step in risk assessment. If you haven't identified a hazard, you can't do anything about it, right? If hazards, the source of risk, are not recognized and identified, risks cannot be assessed, reduced, and managed. The identification of existing and potential hazards within the context of the assessment should be performed. In addition to the listing these hazards, a description or characterization of the hazards should be included. There are many references and resources for common categories of hazards, including OSHA's JHA. So these are the list of hazards on pages 84 and 85. We're going to just go over them briefly. Toxic chemicals, and in OSHA 1910.1000, that's your list of chemicals. If you have chemicals that are above the threshold limit in that list, then you have to be in process safety management. Flammable chemicals, corrosive chemicals, chemical reaction explosions, overpressurization explosion, electrical shock, electrical fire, static electricity, electrical loss of power, ergonomics strain or sprain, ergonomics human error, excavation collapse. You read about this all the time, and it's so sad because it's one of the most preventable accidents around. If somebody's in an excavation of any sort, there are protections that can be done. And if you do a little 5Y on excavation collapse, you're almost always going to come back to human error. And it's never the fault of the poor sucker that got caught in that excavation. Slip, trip, or fall, fire, heat, mechanical vibration, mechanical failure, noise, radiation, both ionizing and non-ionizing, iodizing, struck by something, could be a vehicle, could be a piece of equipment, temperature extreme, hot or cold, lack of visibility, weather, snow, ice, rain, wind. Exposure to hazards. The existence of a hazard alone does not necessarily translate to a risk. Risk is derived from the exposure to a hazard. Therefore, in addition to identifying the hazards, the potential exposure to people, property, assets, the environment, and other things of value must also be identified. We had OK Foods an OSHA inspector, and there was a pulley and a belt which was high up, and I don't know what was running it, a fan or something inside a piece of equipment, and it wasn't guarded, but it was 10 feet off the ground, and there was no walkway, working surface below it, so there was no exposure to it. So did we get written up for it? No, there was no exposure. Had that been 3 feet off the floor, well, it would have been guarded because I've seen it, but it would have been certainly been a hazard and a violation. So exposure to hazards can occur in various ways, including direct contact with the hazard, indirect contact with the hazard. Indirect could be like gases or welding, welding radiation, proximity to a hazard, duration of exposure, magnitude of exposure, concentration or dose of exposure. Possible failure modes. The potential way a system, product, or element can fail and lead to harm should be identified and described. Failure modes are the state or condition where a system fails to perform as expected or deviates from its design tolerances, resulting in the potential for harm or a hazardous event. To identify possible failure modes, the assessor should consider how the process or product can fail in a way that will lead to harm. A simple what-if approach can be used to help identify potential failures in a system by exploring various ways something might fail. You're going to hear this what-if a lot. Examples of failure modes include premature operation. something start, unexpected startup or release of energy. Of course, during service or maintenance, we control that with lockout. Failure to start operation. Sump pump fails to operate when water level rises beyond flood level. Failure to stop operations. Press brake fails to stop when interlock is activated. Failure during operation. Local exhaust system fails during a welding operation. Degraded or deterioration of operation, such as a leak in a containment vessel. Exceeded capacity of operation, overpressurization of a vessel. Reasonably foreseeable uses and misuses of operation, using forklift to raise worker to reach a component. Causes or triggers. It is important to understand the circumstances, conditions, actions, or inaction that can cause exposure to a hazard or trigger a hazardous event. Hazards can be acute in nature, causing immediate harm from a single exposure, while cumulative type hazards develop gradually from prolonged or repeated exposure. There you go, acute and chronic. We've all heard those terms before, and we should be pretty familiar with them. A simple causal analysis can be used to help identify causes that can lead to hazard exposure. Basic causes may include machinery, the design, the selection, the condition, the use, the maintenance, very important, human actions, inactions, knowledge, skill, capability, attention, interaction, communication, management, this direction, supervision, enforcement, communication. There's communication again. Methods, the design methods, the system used, the process, the procedure, the task, the consistency of methods or the consistency of the methods being followed. Materials, elements, constituents, selection, handling, storage, use, disposal. Environment, that's the design or layout, the condition. There's external factors. Hazard identification methods. A number of formal and informal hazard risk identification techniques are available, including those mentioned in this manual and in ISO 31010, as illustrated. We're going to talk about it in the next pages. Each method varies in complexity, application strength, and limitations. The context of the assessment should be considered when selecting methods. In some cases, more than one technique may be needed to properly identify hazards and risks. These are the methods, and that's little, so we're going to look at them on the next few slides. Again, here we are in risk identifications. Brainstorming, workshops, groups. We're going to go into that later. Cause and effect analysis, team-based, used to identify and categorize possible causes and contributory factors. Checklist, list of typical hazards, often taken from industry experience, codes, or standards. Remember on those lists showed of the 3 different organizations and all the things they had, the only thing that was common out of 31 was checklist. I find that kind of odd. Syndetic approach, workshop, semi-structured interviews. Your Delphi technique, we'll have more on that later. Design safety review, structure review of plans, specs, and safety-related factors to identify potential hazards and failures. Failure mode effects analysis, more on that too, and that gets the next chapter. And maybe this one, but I think. Hazard identification study, hazard structural method using guide words or checklists to identify potential causes and consequences, with hazards, causes, and consequences. Hazard analysis and critical control point. HACCP. It's used in the food industry. Placement of control at critical points in a process. HACCP is very common in the food industry. So, hazard and operability study, HAZOP. More involved qualitative approach using guide words to prompt team members to identify deviations that can lead to failure. Human reliability analysis, identify potential for human error. Job hazard analysis, JHA or JSA. Step-by-step listing of a job's sequential tasks, hazards, and controls. Structured interviews, 101 conversations. That's a structured interview. But as I've said many, many times, when you're walking through the plant, looking at stuff, and you see it, an employee, especially if they're looking at you kind of thing, I guarantee you they know who you are. If you're in the safety department, they know who you are. So if you can, if the situation presents itself, you're not going to distract them. If you can stop and talk to them, ask them how they're doing, ask them anything you can do for them. And if an employee calls you over and says, hey, look at this, or hey, what about this? Well, that to me always went to the top of my list, because I want to make sure this employee understood that they bring something to my attention. It's going to get looked at. They can't always do what they think you can do about it. And you can go back there and explain it to, okay, we couldn't do this because of this, but we could do this. And got it to you. People will respect you, and share with you more if you do that. And boy, you want your employees to share with you. Nominal group technique, eliciting a consensus and ranking of ideas from a group. Preliminary hazard analysis, PHA, identify hazards and hazardous situations that can cause harm. Preliminary hazard list used prior to a PHA. Reliability centered maintenance, identify policy to manage failures. I like that, reliability centered maintenance. So that's basically what maintenance is, though. You want this thing to be reliable to work. I mean, your car, you take it in for oil change because you want it to continue working. Scenario analysis, identify possible future scenarios. They come up a lot of these what if things too. Toxicity assessment, identify and analyze environmental hazards and pathways to susceptible population. What if analysis, team-based brainstorming that uses what if to identify deviations and analyze hazards of a system or process. We'll talk about the what if a lot in process safety management too. Hazard identification can be used as a standalone technique or as an initial step in more detailed risk assessment methodologies. Occupational safety and health professionals should have a firm knowledge of hazard types, causes, and consequences, as well as experience in identification methods. A systematic approach to identifying hazards and the related elements is recommended. The following systematic steps are adapted from the MIL Standard 882E. Develop a plan, define responsibilities, initiate a hazard identification process, record and track results, communicate results, record and track hazards, and communicate results. This is a good method to follow. Define responsibility is important. You have a meeting, you say, okay, we find this hazard. What are we going to do about it? Well, let's okay, no, you're going to do something about it. You're going to report it the next time meeting, or you're going to tell us in 2 days or something like that. But you got to get down, define who's going to do something about this. Defining responsibility is an important step. Now we're talking about risk management tool number 7. We're going to use tools used to identify risk for safety professionals. Number 7 is brainstorming. See, I keep my promises. I promise you we'll talk about it some more. Brainstorming is a process commonly used to stimulate and generate a free-flowing dialogue to collect and identify a list of ideas. It is used to generate as many ideas as possible regarding a particular concern or problem. Brainstorming sessions are a relatively quick and easy way of collecting ideas. In risk assessment, it is used to generate a list of potential failures, hazards, risks, and controls. Brainstorming sessions are often used as an initial identification method in a sequence of other analysis and assessment methods. To allow free flow of ideas, the session requires an environment free of criticism or judgment of ideas or items and should encourage participation and creative thinking. Brainstorming is generally performed by a qualified, knowledgeable group of stakeholders and is either structured or non-structured. A skilled facilitator can vastly improve the outcomes of a brainstorming effort. Let's go back. The brainstorming part, here you go. Define purpose and scope, pose the question, generate a list of hazard lists, record that list and complete it, and then finalize the hazard lists. So that's the brainstorming process. And in the brainstorming process, there's no such thing as a bad, initially, there's no such thing as a bad suggestion. People say something, and everybody think, oh, that's stupid. No, it's not. It's brainstorming. So you write it down on a list. The facilitator writes all this stuff down. And then you come up with a list of 25, 35, 40 different things. And some of them are I'm not going to say stupid, but some of them maybe not within the realm of possibility. So then you go back later on and you whittle that down. You get rid of some of them, of course, but you can't do 40 things, but maybe you can get it down to 8. Who knows? So that's the idea of brainstorming, to get the ideas out there, get the ideas flowing. And that also gets other ideas, other people thinking of things. Delphi technique is a good little video in this chapter 2 on the Delphi technique. It's used to gain a consensus on a subject matter from a group of knowledgeable stakeholders or experts. The technique uses a series of questionnaires to collect and collate opinions from a group of experts. An important aspect of the technique is that opinions are made independently and anonymously while having access to other opinions or views during the process. The method used for complex problems or systems to identify risk where the expert judgment is needed. It can be used to identify risks, threats, and opportunities and to gain a consensus view on the likelihood and consequence of future events. It has application of reconciling differences among experts, generating consensus on decisions such as selection of risk treatments, and developing forecasts and policies. The Delphi method works through a number of cycles of anonymous written discussion and argument, managed by a facilitator. Participants in the process do not meet or even necessarily who else is involved. That you want it to be as anonymous as possible. The facilitator controls the process and manages the flow and consolidation of information. The anonymity and remoteness of the process helps to avoid issues of groupthink and personality conflict. More than this, it gives people time to think issues through properly, critique arguments rigorously, and can contribute fully. The process steps are listed in the next slide. Select the facilitator, select all the experts. All these people have to know what you're talking about here. Define the problem, questionnaire responses, and summarize the findings. And this questionnaire responses could be through several different steps. And if you do the short video on this, it kind of really gives you some information on this. It's really a great technique. I personally haven't used it, but it's a great technique. Remember, the people that are in it, they have to be knowledgeable of the subject. A facilitator selected, okay, this is the steps. A facilitator selected to lead the process, compile responses, and communicate the results. Identify the experts. Subject matter experts, we're going to call them SMEs, are selected to provide their opinions and ideas regarding the posed questions. According to this, define the problem, According to the established context of the assessment, the facilitator communicates purpose and specific problem statements to the SMEs. So then you go round one question, a written questionnaire asking specific questions regarding the problem statement, identifying potential and existing hazards related to the operation in this case, is sent to each SME. Each SME individually and anonymously sends their answers back to the facilitator who compiles the results. The summary of responses then is provided to all SMEs for review, but anonymously. Nobody knows who said what or even who these other people are. A second questionnaire narrowing the field or refining the questions is sent again to each SME. Responses are returned to the facilitator, compiled and summarized. SMEs are provided with a second summary. So round three, a third questionnaire is sent to finalize thoughts and gain consensus. SMEs provide the input and the finalized summary is used to determine the finding. Now it doesn't say you can do it in just three, you can do more than that. The facilitator communicates with the SMEs regarding the final summary of findings and the resulting action plan. So again, you could do more in the Delphi technique, but it's a pretty good technique because you're getting, the good thing about it is you have these experts all look at things independently and not having to come up with something right now while you're in front of them and they have time to look at it. So they're going to come up with something that's pretty good. Then they're going to get them all back to the facilitator who's going to compile these and put them out again, but without knowing who did it. So there's no politics involved or groupthink. So it's a good idea. It's a good plan. A good way to do it. All right, risk management tool number 9, hazard identification study. Hazard. A hazard identification study or hazard is a qualitative structured technique using guide words and or checklists for early identification of existing and potential hazards, their causes and consequences. Its purpose is to anticipate, identify, and list hazards associated with an operation, system, product, or task in the first step of the risk assessment. Hazard is used early in the process for existing operations, as well as conceptual or design phase efforts. It is often used in advance of other risk assessment techniques or methods. The technique can include a qualitative analysis to determine the potential severity and likelihood of occurrence, which is sometimes referred to as a risk identification study or risk ID. Hazard is generally conducted by an experienced multidisciplinary team using documents, diagrams, guide words, checklists, and brainstorming to identify hazards, causes, consequences, and controls. Generally, an experienced facilitator and team are used in a workshop setting. The specific part or node of an operation is selected for the study. The process steps are represented below on the next slide. Tools used to identify risk management for safety professional. Hazard. Okay, select the team, gather information, break down the steps, identify hazards, identify causes, identify controls, identify consequences. Select a facilitator and team. Facilitator, scribe, and team of experienced personnel are selected and assembled in a workshop setting. What's a scribe? Well, scribe is secretary, writer, write things down. In Spanish, escribir is to write, so that's scribe. Gather information. Available information regarding the operations gathered for the team to study and analyze. This includes specific checklists or guide words to be used in the study. Break down steps. The operation or element being studied is broken down into components or nodes so that each can be analyzed. So this is the hazard flow chart. Select a node, use guide words to identify hazards, Hazard possibles, yes. Brainstorm cause and consequences. Identify controls and record those. Identify potential hazard. Using guide words or checklists, the team determines which potential or existing hazards should be studied for the component or node. These are recorded in the hazards column of the hazard worksheet. Hazard guide word examples like fire explosion, mechanical failure, utility failure, thermal, chemical and substances, natural disasters, environmental conditions, corrosion, human factors, errors, electrical, ignition sources, dropped objects, collisions. A lot of hazard words can be thrown about there. Identify causes. For each hazard, the team identifies possible causes or triggers that can lead to a hazardous event or exposure, which are recorded in the causes column. Brainstorming, document reviews, interviews, and site observations can all be used to identify triggers and causes. Identify controls. For each hazard, the existing controls are identified and briefly described. Okay. It's funny they don't mention you use the hierarchy of controls. Identify consequences. For each hazard, the potential resulting consequences are identified and recorded in the consequences column. So this is the hazard thing here. We'll look at this in a bit. Biodiesel manufacturing, methanol storage tank. The hazard, thermal expansion, methanol vapor generation. The cause, faulty blocked vent, excessive in-tank vapor generation. Consequences, overpressurization, loss of containment, property and tank damage. Number 2, corrosion, methanol tanks, trim and piping. Incompatible tank and trim material, the causes, consequences, loss of containment, methanol product loss. Human factors, errors, methanol tanks overfilling, cause, distraction, miscalculation, consequence, methanol product loss. Environmental conditions, carbon steel tank corrosion, cause, proximity to ocean and salts, again, product loss. Natural disasters, methanol tanks piping, earthquake, storage system not designed for seismic activity, going to have product loss. Ignition sources, bonding and grounding, static discharge, inadequate conductivity in bonding and grounding, damage to equipment from fire and explosion. Serious damage going on there. So design safety review. A design safety review is used to anticipate and identify potential hazards during the design and redesign process of new facilities, expansions in existing buildings, new or modified processes or systems, equipment and machines and products. The purpose of a design safety review is to avoid anticipated hazards through design of a new system or redesign of an existing system. Application design safety reviews are most effective when performed at an early stage when design objectives are being discussed according to Z590.3 and should be considered in any major plan change. And that makes a lot of sense if you're having some kind of change going on to be involved in the design up front. Design safety review process is a systematic method used to anticipate, identify, avoid, eliminate, and control hazards at the design stage. Management commitment and support are required to integrate prevention through design concepts. PTD, prevention through design. Design safety review process, management policy, project design leader and team, establish a review process, conduct a hazard analysis and risk assessment, no deviations without approval, design complex sign-off and action plan. No deviation without approval, which means deviations are allowed. So there's a lot more details on this page 99 to 101. So I'm not going to get into a lot of that right now. So that is there's your references just to make this thing legal. That is the risk identification portion of this, the very important portion of it. So read that chapter carefully. It's important. If you don't identify these risks, you can't do anything also. In the meantime, be safe.